we're going to talk about the derivative of hyperbolic functions. The derivative of hyperbolic functions gives the rate of change in the hyperbolic functions as differentiation of a function determines the rate of change in function with respect to the variable. We can evaluate these derivatives using the derivative of exponential functions, which is e raised to the power of x and e raised to the power of negative x. Along with other hyperbolic functions, formulas, and identities, we have 6 main hyperbolic functions, namely sine hx, cosine hx, tangent hx, cotangent hx, secant hx, and cosecant hx. So, where do hyperbolic functions come from? We know where trigo comes from. It comes from a unit circle x squared plus y squared equals 1. So this point would represent cosine of x, sine of x, and we can also find these using the ratio of a triangle. So here we have sine is equal to opposite of our hypotenuse, cosine is adjacent of our hypotenuse, but where do hyperbolic functions come from? Well, they actually come from the parabola x squared minus y squared equals 1. And so here we have the theta is equal to this entire angle, and this corresponding point is hyperbolic cosine of theta, hyperbolic sine of theta. We can actually write this in terms of x, so the hyperbolic sine is equal to e raised to the power of x minus e raised to the power of negative x divided by 2. And hyperbolic cosine of x is equals to e raised to the power of x plus e raised to the power of negative x divided by 2. Using this 2, we can find all the other hyperbolic functions by using their ratios. And here we have the formulas for all the hyperbolic functions. In this video, we're going to focus on the derivatives of hyperbolic functions. So let's start with the derivative of hyperbolic sine. This is equal to hyperbolic cosine. So you may want to take some notes on this. We'll work on a few practice problems shortly. The derivative of hyperbolic cosine is hyperbolic sine. It's a little bit different from the corresponding trig function. In trig, the derivative of normal sine is just cosine, but the derivative of cosine is negative sine. But for hyperbolic functions, the derivative of hyperbolic cosine is positive hyperbolic sine. The derivative of hyperbolic tangent is hyperbolic secant squared. The derivative for hyperbolic cosecant x is negative cosecant or hyperbolic cosecant times hyperbolic cotangent of x. Now the derivative for hyperbolic secant x, that's negative hyperbolic secant times hyperbolic tangent. Now the derivative for cotangent is negative cosecant squared. derivative. If you recall, hyperbolic sine, it's e to the x minus e to the negative x over 2. Let me make sure I have the right formula, because sometimes my memory may fail me. But that is the correct formula, so that's hyperbolic sine. And hyperbolic cosine, it's the same thing, but the only difference is we're going to have a plus sign instead of a minus sign. So to differentiate hyperbolic sine, we're differentiating that expression e to the x minus e to the negative x over 2. The derivative of e to the u is e to the u times u prime. So the derivative of e to the x is e to the x times the derivative of x, which is 1. So that's just e to the x. The derivative of e to the negative x is e to the negative x times the derivative of negative x, which is 1. So we get that. So this becomes e to the x. These two negative signs they cancel, so it's plus e to the negative x over 2, which is what we have here, and that is equivalent to hyperbolic cosine. So that's how you can prove this particular derivative. Now let's work on some practice problems. Go ahead and differentiate hyperbolic sine of 4x and also hyperbolic cosine of x cubed. Feel free to pause the video as you work on this. The derivative of hyperbolic sine of u will use a function of x as opposed to just x. This is going to be hyperbolic cosine of u times the derivative of the inside, or u prime. Hyperbolic cosine will keep the inside part the same, 4x times the derivative of 4x, which is 4. So it's 4 hyperbolic cosine of 4x. So that's how we can find the value of that derivative. For the next one, derivative of hyperbolic cosine, we know it's hyperbolic sine. We'll keep the inside the same and we'll take the derivative of the inside. The derivative of x cubed is 3x squared. We write the answer as 3x squared hyperbolic sine of x cubed. Let's try some more examples. Go ahead and find the derivative of hyperbolic secant x to the 4th. And let's try the derivative of x squared hyperbolic sine of x. Let's try those two examples. So the first one, we just have to use the chain rule. The derivative of secant is secant tan, but with a negative sign. So we're gonna have hyperbolic or negative secant times x to the 4th and times hyperbolic tangent x to the 4. Then we need to differentiate the inside. The derivative of x to the 4th is 4x cubed. We can rewrite this as negative 4x cubed hyperbolic secant times x to the 4th times hyperbolic tan times x to the 4th. Alright, so moving to the next one, we have product rule, and if you recall, here's the product rule. We have f times g. We want to find the derivative of that is gonna be f prime g plus f g prime. So this is f and hyperbolic sine is g. So f prime, the derivative of x squared is 2x times g, will keep that the same, plus f, which is just x squared, times g prime, which is gonna be hyperbolic cosine of x. So that is the answer for the second practice problem. Now let's try a natural log problem. Go ahead and find the derivative of ln, hyperbolic sine of x. And try this as well. The derivative of ln, hyperbolic cosine of x squared. Just a preview. When you're finding the derivative of ln u, we're using the function of x. It's gonna be u prime over u. In this example, for the first one, u is hyperbolic sine of x. U prime is the derivative of hyperbolic sine, which is hyperbolic cosine of x. This is gonna be hyperbolic cosine of x over hyperbolic sine of x. And cosine over sine, that is cotangent. So the final answer is hyperbolic cotangent of x. Now for the next one, we see that u is hyperbolic cosine of x squared. U prime, the derivative of that, is the derivative of hyperbolic cosine, which is hyperbolic sine, and we'll keep the inside part the same. And the derivative of x squared is 2x. So u prime over u prime is 2x hyperbolic sine of x squared divided by the value of u, which is hyperbolic cosine of x squared. Sine over cosine, we can make that tangent. So the final answer is going to be 2x times hyperbolic tangent of x squared. So those are some simple ways in which you can differentiate a hyperbolic function. As you can see, the rules are pretty similar in differentiating other functions using the product rule, the quotient rule, and the chain rule. And now let's go ahead and differentiate hyperbolic sine of 4x and hyperbolic cosine of x cubed. Feel free to pause the video as you work on this. The derivative of hyperbolic sine of u is hyperbolic cosine of u times u prime. So for this is gonna be hyperbolic cosine of 4x times the derivative of 4x, which is 4. So it's 4 hyperbolic cosine of 4x. So that's how we can find the value of that derivative. For the next one, the derivative of hyperbolic cosine, we know it's hyperbolic sine. We'll keep the inside the same. Take the derivative of x cubed, which is 3x squared. So we can write the answer as 3x squared hyperbolic sine of x cubed. Now let's try some more examples. And find the derivative of hyperbolic secant of x fourth, x to the fourth, and the derivative of x squared hyperbolic sine of x. Try those two examples. The first one, we just have to use the chain rule. The derivative of secant, negative hyperbolic secant of x to the fourth times hyperbolic tan of x to the fourth. And we need to differentiate the inside part, which is 4x raised to the power of 3. So the answer is negative 4x cubed hyperbolic secant of x to the fourth times hyperbolic tan of x to the fourth. Alright, so moving to the next one, we have the product rule. If you recall, here's the product rule. If we have f times g, derivative of that is f prime g plus f g prime. So this is f and this is g. So f prime, the derivative of x squared is 2x times g, will keep that the same, plus f, which is just x squared, times g prime, which is gonna be hyperbolic cosine of x. So that is the answer for the second practice problem. So now let's talk about how to evaluate hyperbolic trig functions. So what is the value of hyperbolic sine of 0? In order to find that answer, we need to know the formula of hyperbolic sine of x. It's equal to the exponential function e to the x minus e to negative x divided by 2. So all we need to do is substitute x in the formula. So it's e to 0 minus e to negative 0 divided by 2. Anything raised to the power of 0 is 1. It's 1 minus 1 over 2. So it becomes 0 over 2, which is 0. So that is the value of hyperbolic sine of 0. It equals to 0. Let's try another example. This is the value of hyperbolic cosine of 0. Feel free to pause the video if you would like to try the example. First, we need to know the formula of hyperbolic cosine of x, which is e to x plus e to negative x over 2. So this is going to be e to the 0 plus e to negative 0 over 2. This is 1 plus, which is e negative 0 is 1, so this is 1 over 2. So the answer is 2 over 2, which is 1. So the hyperbolic cosine of 0 is equals to 1. Much in the same way where hyperbolic sine is equals to 0. Let's try this one. Is the value of hyperbolic sine of ln2. Go ahead and work on that problem. This is going to be e to ln2 minus e to negative ln2 over 2. Now, what is e to the ln2? When dealing with natural logs, the base e here, these cancel out, you just get 2. For the next one, this negative 1, I want to move it here to the exponent of 2 as a property of log. This will be ln2 minus 1. 2 to negative 1 is the same as 1/2. So these will cancel. I'm just gonna get 1/2 here. What I'm gonna do is I'm gonna multiply top and bottom by 2 just to get rid of the fraction. So we have 2 times 2, which is 4. 2 times a half is 1. And on the bottom, 2 times 2 is 4. 4 minus 1 is 3, so I'd get 3/4. So that's the answer. That's the value of hyperbolic sine ln 2, which is 3/4.